All right, so welcome to the example video for the Pythagorean theorem. So we're just going to be looking at three examples. Um, so you can see in all three of these, we're dealing with right triangles. Remember, that's important with the Pythagorean theorem. They have to be right triangles for this to work. What does the theorem say? It says if we have the leg squared plus the leg squared equals the hypotenuse squared, right? Um, So what you always got to be asking yourself is what is the missing side length that I'm looking for? Notice in all of my examples, they're going to be marked with an X. We're going to be practicing this on Khan Academy. They're going to be doing the same thing. They'll always be marked with an X. That's the side we're looking for. So in this case, I'm asking myself, am I looking for a leg or am I looking for a hypotenuse? That's where you always want to start. In this case, I'm looking for the hypotenuse because it's not a part of the 90-degree angle. So I'm looking for the hypotenuse. And then what I'm going to do from here is I'm going to make squares off of all three sides every single time because we know the area of the two smaller squares equal the area of the bigger square. So we just start out by labeling the areas of the squares I know, right? Because here I had the side length is 3, so we know this one's 3, so 3 times 3 is 9, right? Or this side length squared. The area of this one is going to be 6 times 6, or 6 squared. The area here is 36. And then this one I don't know because it's x. And so to figure out what we have here, since it's the hypotenuse, I know I'm adding the two legs together, the legs squared, right? So I'm adding the two areas together. So that's just going to be 9 plus 36. So this whole area is 45. Right? But I'm not looking for the area of this big square. I'm actually looking for this side length. So to figure out what this side length is, that's where we're applying what we did in the last essential. So to figure out what x is, I know that x is the side length of the square. So x times x, or x squared, is going to be equal, right, to 45, because that's the area of the big square. And then I can just solve this equation. Right? How do we solve when there's the square? We find the square root. So I take the square root of both sides because the square and the square root are opposite and they cancel out, leaving me just the x. And then here we're looking for the square root of 45. That's where I'm going to pull out my little sheet and I'm going to look for 45. And I see it's going to be less than 49, but bigger than 36. So the answer is somewhere in here, right? So again, we're just going to eyeball it. 45 that looks a little closer to the 49, so I'm going to go a little closer to 7. So I'm going to go 6.7, right? We're just guessing. 6.7, right? So what's the missing side length here? It's going to be 6.7 is my final answer there. Okay, and remember we talked about that the hypotenuse is always going to be the biggest side. So you should always just take a real quick second and check that the number you found makes sense. So if the hypotenuse is the longest side, is the number I found the biggest number? Well, this one's 3, this one's 6. 6.7 is bigger than both of those. So it makes relative sense. Also, a very common mistake some of us make is we forget to actually take the square root of this number. And again, that if we check for reasonableness, that doesn't make sense. In the triangle, if this one's 3 and this one's 6, it doesn't intuitively makes sense that the number here should be 45, right? So if we just take that real quick second to check, does the number make sense, right? That would tell us, oh, wait a second, 45 is way too big. That's right. I have to take the square root of 45 to get the actual number. Okay, so let's just do another example. So again, it's a right triangle, so we can use the Pythagorean theorem to find this missing side length. Now I'm asking myself, what am I looking for? Am I looking for a hypotenuse or a leg? In this case, I'm looking for a leg because it's part of the 90-degree angle. Okay. So I'm going to be looking for a leg, which means it's not going to be the biggest number. So it's going to be smaller than 10, because 10 is the hypotenuse, because it's opposite the 90, or it's not a part of the 90. So when I'm all done, I'm looking for a number that's smaller than 10. That's all I know at this point. Okay, so at this point, I'm going to create my 3 squares off the side of the triangle, fill in what I know, right? So here, I'll just start here. The area of this one is going to be that number squared. So 10 times 10 is 100. Here I can find the area because I have this number. So to find the area here, you're taking this number squared, or 7 times 7 is 49. And then we got to find this area. Now over here what we did is we added, but that's because the theorem says leg squared plus leg squared equals the hypotenuse squared. So it's this thing plus this thing should equal 100. Well, since I'm looking for this piece, right, I can't add these two numbers to figure it out. So if I'm thinking what number plus 49 is 100, how we figure that out is I just subtract, right? I just take 100 minus 49. Okay, so that's why we're kind of also asking ourselves, am I looking for the hypotenuse or if I'm looking for one of the legs? Because if I'm looking for the hypotenuse, I'm going to add the two little squares together to get the big square. If I'm looking for a leg, right, I'm going to have to take the big square and subtract out one of the small squares to get the other small square. Okay, so finishing this up, 100 minus 49 gives me 51. And then again, if I forgot to do the next step, I would check my reasonableness. That's 51. Wait a second, it was supposed to be smaller than 10. That's not right. Oh, that's right, because that's the area of this little square. Okay, so to find what the length is, you're going to take x squared equals 51. To undo the squaring, I'm going to use the square root. So I'm going to take the square root of both sides. The square and the square root cancel, leaving me just x. Over here, I'm looking for 51, so I'm just going to take out my chart again. I'm looking for 51. It's not on my sheet. It's a little bit bigger than 49, but smaller than 64. So again, it's somewhere in between 7 and 8, and it's much closer to 49. So I'm just going to go with a number a little bit bigger than 7, right? 51 is just a little bit bigger. So I'll go with like 7.1, right? So here, what is x equals? X equals 7.1. That's what that missing side length is. And again, if you check the reasonableness, it was supposed to be smaller than 10, and it is. So everything kind of checks out there. And then we are on to our last one. And really what I want you to pay attention to is they're not always going to be sitting on one of the legs, right? And sometimes that throws us off to which one is the hypotenuse. So you just got to always pay attention to the right angle. The right angle tells us what our legs, what our hypotenuses are. Because remember, the legs make up the 90. So these are going to be the two legs. This is the side that's not a part of the 90, or it's opposite the 90. So this is my hypotenuse. So again, I'm looking for the hypotenuse, which means I'm going to be adding the two legs together. So here I'm going to be adding the two squares. So first I got to find those two squares. So I'm going to just build those two squares. Right? So the area of this square is just 5 times 5, or 25. The area of this square is 12 times 12, or 144. Right? And then to find the area of this square, since it's the hypotenuse, that tells me it's the biggest square here. So that means I'm adding the two little squares together. So here I'm just going to take a 144 plus the 25 gives me 169, right? And then again, if I forgot and I checked for 169, that's obviously way too big, given it's 5 and 12. So what do I need to do? I got to take x squared equals 169. I'm going to undo this squaring with square roots. So I'm going to take the square root of both sides. That gives me x equals. I actually did update my chart the other day with 13. So I do have that. Remember I told you as you get, sometimes you might run into numbers that are a little bit bigger than what's on your chart. Then what I would do is just add them into your chart as you go. So here I do have the square root of 169 is 13, right? So the answer to the square root of 169 is 13. So this missing side length here is 13. X is 13. Okay, so that's the general idea. If you have any questions, send me an email.